you'll be pleased to know. So without further ado, today's topic is about life cycle analysis. So we've all heard the sustainability topics and maybe heard even a bit too much about them in recent months and years. But look, this is a hugely important topic. I've personally been working with one of our speakers today, Jon McKechnie, for the last, say, 12 months to 2 years. And I have to say, where I thought I was well read on this particular topic, I've learned such a great deal from Jon. It's one of the reasons really that we've really hounded Jon a little bit to do a presentation for us today and hopefully just pass on some of that knowledge to you guys. And so, you know, without further ado, I'm going to pass on to Jon. So Jon, if you wouldn't mind turning your camera on there and unmuting yourself. And I really hope everybody else enjoys Jon's presentation as much as I have done in the past. But yeah,
I'll do my best. I'll try not to disappoint, Liam. But please wave your hands frantically if I start going on a bit and taking too long. I may flip into lecturer mode anytime here. So,
thing, Jon, if you do want to introduce yourself ever so briefly.
Yeah, we'll do. Yeah. So my name is Jon McKechnie. I'm an associate professor at the University of Nottingham. So I'm in the mechanical engineering department there. My background is looking a lot into life cycle assessment and costing, looking at material flow analysis, etc., and other tools for evaluating the sustainability of new technologies. And so, like Liam said, we've been working a bit with Benchmark in the last year or so, and trying to, I guess, work together to better understand some of the sustainability challenges when it comes to packaging materials. So I'm just going to quick pop up my presentation here. Just bear with me a moment. Should be loading. Excellent. I can see the presenter mode. Can you guys see the full screen version?
Yeah, that's looking good, Jon.
Okay, super. Thanks. Great. So as Liam was saying today, what I'm looking to do is to very briefly talk a bit about the drivers for sustainable packaging. I'm sure that those on the call are probably more familiar with that, the particulars of the sustainability drives in the packaging industry than myself. From there, I'll introduce life cycle assessment methodology and how we can apply that to packaging to better understand those sustainability challenges and some of the opportunities that we have to address them. And I'll end off just by very briefly mentioning some of the research initiatives that we have at the University of Nottingham within my group that are related to these topics. So just very quickly, looking at some of the drivers that we see behind packaging, I think of course the last couple of years, the environmental message that's been dominating the news is looking at climate change and student strikes for climate and Greta Thunberg, and really an increasing sense of urgency that we need to be making very quick action to try to address the greenhouse gas emissions that are associated with all aspects of production and consumption in our economy. And of course that's as relevant to packaging as it is to other products out there. We also, of course, have the David Attenborough effect and the issues that have been raised, looking particularly at plastic pollution, which is a growing issue with potentially large ecological impacts, and certainly very visibly being able to see the impact of human activities and the economy on the natural world. And alongside that, we also have drivers coming from the circular economy perspective of looking at the resources that we're consuming and trying to identify ways that we could use these resources more efficiently. Now the figures that I have up here are from I gathered a couple of years ago for a talk that I gave for Pint of Science, looking in general at waste management and opportunities there, and looking at the recycling rate in England. We can see overall that we're not doing as well as we would like to be, and we have a 50% recycling target for household waste in England. We're very unlikely to meet that by the 2020 deadline. Now, packaging, of course, is only a part of this waste stream, and if we look specifically at the recycling rates of packaging, we will see higher rates of those packaging materials because of the extended producer responsibility. But at the same time, a lot of that higher recycling rate is being met by exporting our waste to other countries, formerly to China, currently more likely to countries such as Turkey, where there's questions or concerns about how effective the recycling processes are in those countries, and how much we're actually able to recover value from those materials. And certainly we see through the Ellen MacArthur Foundation and other circular economy initiatives this drive to be making sure we're making better use of those resources, that we can put them back into the same high quality uses that they've had initially, so we can retain that value and keep those technical materials cycling through our economy, rather than having a more or less a single pass through with maybe some down cycling through less effective recycling processes at the end. So quite a lot of drivers that come in here, and overall it becomes quite a complex picture. We have a number of different objectives we're trying to address, and a class of materials, packaging materials that are quite diverse, of course. And so here's where, with talking with Tim and Liam, certainly we see a value for life cycle assessment as being a useful tool that we can use to try to put some numbers to these arguments, to better inform these decisions when we're looking for alternative ways forward of providing packaging. So I'm sure that most people on the call will have at least heard of life cycle assessment. What I'm aiming to do today is just cover in relatively briefly the key aspects of LCA, and then get into a little bit more detail for how we could apply this to packaging materials and what sorts of questions we'd be wanting to ask. So life cycle assessment, we use it a lot as a research tool. It's a very useful tool for being able to quantify the environmental impacts of a product or of a process. Essentially, what we'll do is we'll look at, through the relevant activities that occur over a product's life, we'll keep track of the material and energy inputs that are being consumed by these different activities. We'll look at the emissions that are occurring as well, and essentially we'll total that all up, and we'll end up with a total environmental impact over the full life cycle of this product. Or this process, and so the LCA methodology itself is standardized. There's ISO standards. But when we're designing an LCA study, we're always applying it to a specific project goal or a specific research question that we're trying to ask. And so there's a lot of power of the LCA practitioner to design that study and to tailor it to make sure that we're getting an appropriate answer for the question that we're trying to ask. And ultimately, what we're looking to do with LCA is to help to inform that decision making. So whether we're trying to select between different options, looking at a new opportunity, comparing it with the incumbent, or if we're evaluating an existing product and trying to identify areas of concern for particular environmental impacts or resource consumption issues, we can use life cycle assessment again to put some numbers behind these discussion points and help to inform those decisions going ahead. Now, the key to a life cycle assessment study, of course, is that we need to have information that's covering the whole product life cycle. And I forgot that I have these next bit animated, so apologies. But we need to go all the way back to the point where we're initially extracting resources, where we're converting those resources into a primary material. We're then going through manufacturing processes to get to a finished product. That product is then going to be used in some capacity before it reaches its end of life. And when we get to that end of life stage, of course, then we need to consider the different options that are available for us. Are we going to go through to a more conventional disposal route, such as landfill or incineration? Are we going to try to recycle or reuse or remanufacture this product? And again, making sure that we're encompassing all of these relevant activities. And it's really it's only when we get that full scope of everything that's happened to produce this product, to use it, and to manage it at its end of life, that we can really fully understand that total environmental and resource consequence of this product or process. And so the main reason why I want to be using this here, so where LCA fits in as a tool, is it gives us that whole system consideration for comparing products or processes. We're not just going to be looking at a single activity or a single aspect of this product. We're going to take everything into account. So we have that full view. If we're changing a material, for example, we'll be able to account for how that's impacting the performance of our product, the implications at end of life. So we're not going to be misled by just looking at a single at a single activity or a smaller set of activities. It's also going to, if we do it right, we're going to be able to produce a consistent framework. So if we want to compare between different product or process options, we can develop an LCA study so that we're comparing them fairly, thinking about the function that these products are actually delivering, and ensuring that we're comparing it on an apples and apples basis. We can also use this approach to identify trade-offs, and here's where I think all decision-making, of course, is made about balancing trade-offs. So between different environmental factors, greenhouse gas emissions versus resource consumption versus ecological consequences. But of course, we have to balance those environmental issues also with social impacts, job creation, financial issues, return on investment, etc. But again, it's giving us that information that we need to help to understand where these trade-offs exist, to have numbers behind it so we can quantify, so we can optimize these decisions that we're making as much as possible going forward. And so with this sort of perspective in general, with LCA, we can use this to help to guide our material selection. If we're looking to look at new production processes, design of products, applications of products, etc. Again, we can use this as a tool to help to inform those decisions. And also when we get to take it from a more of a top-down view, we can also use LCA as a tool to help to evaluate or even to inform policies and regulations that exist or that are being developed. And certainly we can see life cycle assessment being used quite a lot in the biofuel space, both in Europe as well as in North America, to quantify greenhouse gas emissions of biofuels in order to be eligible for subsidy support and to qualify as renewable fuels. So a very important role for LCA there in the policy space. And so, as I've mentioned in one of the earlier slides, there are existing standards for LCA. So there's ISO standards. The ILCD also historically has provided guidance for developing LCA studies and collecting data and quantifying impacts, particularly for a European context. So there's established standards, but there's still a lot of flexibility and a lot of I guess when we develop an LCA study, we're making a lot of decisions that could have a significant impact on the results. So it's important that we understand how the LCA study is being constructed so that we can interpret the findings and take a lesson from that. In general, an LCA study is going to include four distinctive phases. So the first and probably the most important stage is to define what the goal and the scope of the study is. And so this is really where we're being clear about what question we're trying to answer. Are we trying to understand the environmental impacts of a product? If so, which environmental impacts? Are we trying to compare different alternatives, etc.? And making sure that we have a very clear statement of that goal is important, because every decision that follows from that is based on trying to best answer that question. From there, again, so we'll select the activities that need to be included in our study, and then we need to collect our inventory data. So looking at the mass and energy flows that are occurring for every stage of making, using, and disposing of our product. We then take those inventory items, so looking at our material, energy inputs, and our emissions, and we correlate those to environmental impacts. So that makes it easier to understand that overall aggregated impact. And from there, we then have some evidence we can use. We need to interpret that to try to answer the question that we started off with at the beginning of the whole process. So how can we apply this to packaging? So rather than look at specific examples of packaging products and looking at environmental impacts of those, I thought we could just take with the time that's available, just take a quick view at what I think are some of the key aspects that we need to be covering in a life cycle assessment study to really understand that overall impact of the decisions that we're trying to make. And so I'll just go through each of these four topics. So certainly looking at our material selection, the material that we're producing our packaging from, or materials in many cases. Also thinking about the efficiency that we have of producing the packaging materials and products. Looking a bit at the functionality of the packaging and how our different options might be able to fulfill that functionality differently. And then finally getting to the end of life management of our packaging materials. So if we look to material selection here, I think certainly every time I go to the grocery store, I can see the pressures on the packaging sector in real life, where we see this drive to be shifting from petroleum-based plastics towards alternative materials, seeing increasingly use of biodegradable plastics in grocery stores, but also an uptake of more conventional biodegradable materials like paper and cardboard being increasingly used. And so here, I think we have some very important decisions thinking about our material selection that will have very different consequences. On one hand, if we look at our petroleum-based plastics, we have a very efficient system that can produce a lot of product with a very small footprint. But of course, with all the impacts associated there as well. If we try to diversify or transfer to more renewable materials, what we have is much more distributed production. We end up having to occupy a lot more land in order to produce these materials, and so we need to understand the consequences there of utilizing those biomass resources on the carbon stocks that our forests and our farms are able to hold. The competition for other land uses, and also the ecological impacts that we have of managing land for productive uses like this. Now, one of the exciting areas of research that I'll get back to very briefly later on in the talk is looking at renewable alternatives to plastic. So either chemically identical materials, for example, making polyethylene from ethanol via sugarcane or corn, but also increasingly looking at alternative polymer materials that are biodegradable, that are potentially more compatible with a circular economy model. But again, thinking about the feedstocks we would need to produce these is really important questions to be taking into account. The next stage, if we think about the actual production of producing packaging, now here I know that Tim and Liam will be talking a bit more about this later. Here, of course, we need to be going from our raw materials into our actual packaging product, and what we have is a lot of complexity here, a lot of different material inputs coming in. Our inks, our adhesives, our plastics, our paper, our card products, but also going into very different packaging production processes. So we have different types of equipment that'll have different energy efficiency, but also that the same piece of equipment we can use differently with different lengths of print runs that will be influencing the amount of wastage that's produced, the energy efficiency of producing this packaging as well. And so a lot of complexity, a lot of detailed data that we need to have in order to evaluate all the variability that we might see within a packaging production environment. Moving on, looking at the functionality of packaging, I think this is one of the, if I was giving one of my undergraduate lectures, this is a point I always try to get across, is looking at the functionality. Of course, packaging is a product itself, but its main purpose is to deliver another product to a consumer or within industries. And so we need to make sure that if we're considering different alternative materials, that we're retaining or maybe even improving the functionality of that packaging to keep those products safe. I think in the examples on the slide here, if we're looking at eggs or we're looking at strawberries, for example, if we have a packaging alternative that's going to lead to a higher risk of eggs being broken or a shorter shelf life for those strawberries, most likely, even if we have a zero carbon packaging solution, we're probably overall not going to be delivering a benefit, because the production of that product in the first place does itself have some environmental consequences associated with it. And so making sure that we understand these linkages between the material selection, the design of that packaging, and its functionality to protect the products it's delivering is absolutely essential. And the final point that just to bring in today is thinking about that end of life and thinking towards how we're going to be dealing with this packaging product at its end of life. And of course, for most packaging, what we see is if we think of it as a product, it's a product that has really a very short shelf life. It's delivering that service of delivering a product from one place to another and keeping it safe during that, at which point it's typically going to become a waste product. And the consequences of managing those wastes is really going to depend on its compatibility with different end-of-life management options, but also the availability of those systems. So here in Nottingham, we have a lot of our residual waste is going to an incinerator, and that includes to some extent packaging materials that haven't been recycled. biogenic materials, it's great, we can recover the energy value, but if we're putting plastics into an incinerator, of course, we're releasing all that fossil carbon that's contained in the plastics, and overall our greenhouse gas emissions balance is not going to be favorable. But certainly understanding, again, how our design of our packaging, how the material selection influences its compatibility with better options at the end of life is really important. How easy will it be to recycle and to recover high quality materials from this packaging at its end of life is absolutely essential. Or also thinking, of course, towards reuse of packaging. In the good old days, when we used to get to pay deposits on glass bottles and get a little bit of pocket change back when we were able to take those back to the corner store. So that's a very quick overview of my perspective anyway. So take it for what it's worth of the key aspects we'd want to be looking at in an LCA of a packaging product. And what I hope I was able to convey here is that really, if we're trying to understand that big picture, that overall environmental and resource implication of a product such as packaging or any product, it's very complex. There's a lot of different factors we need to be thinking about across that product life cycle, different decisions that we could make that are going to have implications upstream as well as downstream. And it would be very easy for us to mislead the decision making by just focusing on a single aspect. If we were just focusing on the renewability or the biodegradability of a material and not taking into account all the other aspects of that life cycle, we're potentially going to make a decision that doesn't deliver the benefit that we're expecting it to, or in the worst case scenario, is actually making the problem worse. And so here's where we see this value of life cycle assessment in general as a tool where we can provide that consistent framework, so we can take that full comprehensive understanding of a product and of the options, and really to be able to feed that into our decision making, so we can balance trade-offs between our environmental resource, financial and social drivers that are part of that decision making process. I'm keeping my eye on the time here, Liam. I think I'm doing okay. I've just wanted to very quickly touch a bit more about the research activities that we're involved with in this area. So at the University of Nottingham. So just highlighted 4 of the areas that we're active in, that we're applying LCA and related methodologies. We do quite a lot of work looking into biorenewable materials and fuels, and so here we're looking into routes to produce either chemically identical polymers, or also novel polymers that we can produce from renewable, sustainable resources, often from wastes, and also thinking ahead towards how we can make sure we can recover value from those materials in a circular economy model when they reach their end of life. We do quite a bit of work looking at recycling technologies and circular resource management. When we have residual materials, we look quite a bit at how we can recover fuel and energy value from these. And of course, again, taking that more top-down view, is we also see that we also take into consideration the role of LCA and similar tools on the policy analysis side, and helping to inform that economy-wide transition towards net zero across single product categories, but also thinking of sectors and how they interact together. I could talk about all this stuff for days on end. I'm not going to, though. But thank you all for your attention. Thank you for Liam for the invitation, the opportunity to talk today. I'm happy to take any questions now, or are we going to save those until the end, Liam?
Save those to the end, if that's okay, Jon. Just Perfect. To say, Jon, thank you so much. Knowing the detail and the breadth of the topic that you are an expert in, to cover that off in what amounted to 20-25 minutes was remarkable. So thank you very much. And look, hopefully to everybody else on the webinar today, at least if there's one message that should probably clearly come through, this is a very, very complex area. And it kind of leads me on to our next speaker today, Tim Barbary. I call him Dad. You're welcome to do the same. Yeah, Dad's going to talk about really a practical example now of that breadth and complexity that you hear Jon talking about. How does that translate into a model that we can all use and understand in our industry? And you know, my dad and the rest of us at the team of Benchmark, there's then here's one idea, here's one solution of how this could look if you did want to model different specifications against each other and things like that. But Dad, without further ado, I'll pass on to you, and if you want to just introduce yourself to those who might not know you, and progress with your presentation. Thank you.
Just checking you can hear me okay, and you can see my slide.
Yeah, That's perfect. Thank you.
Okay, so yes, good afternoon, everyone. My name is Tim Barbary, otherwise known as Dad to Liam and his sister. I've been part of the Benchmark business, which started 10 years ago, primarily with the objective of being able to enable people to better understand prices of packaging. More recently, what we've done is we've extended this to now capture the carbon emissions at every point of the packaging process. And the significance here is from the bottom up. In other words, from an SKU, you would know the value of the packaging. Our business has been working alongside Jon and his team. Jorge, I think, is on the call, but I won't go into the full details of that. My background is pretty much one of procurement, buying packaging, and never understanding why on earth prices varied the way they did from one company to another, same company, different location, or even different parts of the world. Trying to better understand that was always a problem. Trying to get to the bottom of CO2e was an even bigger challenge. And I'm hoping that I don't have to say anything for the next 2 minutes. When I first saw that produced, I thought, my God, that's my 40 years working career summed up in 2 minutes. Liam somewhat unkindly said, I'm still surprised it took that long. Anyway, we didn't do it alone. You've obviously gathered we've done work with the University of Nottingham. We've also got access to EcoInvent, which is a very wide and well-respected database of carbon footprinting data used in life cycle analysis. Because energy just changed from country to country, Poland, for example, would have far more coal to produce their electricity than the UK, and that in turn impacts on the amount of carbon that's emitted in production in those countries. We're also working with a commercial life cycle analyst. He, along with the university, has seen what we're about to demonstrate to you. And we've also been working with industry leading manufacturers. They're not always keen for us to publish who their names are, so I can't share them here. And of course, there is my 40 years experience, Liam's 20 years experience, and other members of the team, which is quite extensive. Now, it's not just about us, it's also what's going around in the packaging industry. Packaging waste has obviously been mentioned by Jon, and CO2e is something that's now moving along as well. And the younger generation, if I can use that phrase, is far more concerned than my generation, which is a great pity. That said, retailers and brands are being very sensitive, and they're listening and they're paying attention, and what happens now with social media is a very different animal to even 10 years ago. But we've got to act sensibly and rationally. Impulsive actions are often good, but they don't usually get to the bottom line. And also from a consumer perspective, from Netflix, we can see that labels on packs don't always get the credit in terms of, is it genuine in terms of the labeling. The information I previously shared was from Mintel, but in addition to that, I can share with you that the Carbon Trust has done research as well, believing that consumers are more likely to think positive about brands and retailers that demonstrate lower CO2e. Deloitte, one of their big things was that lifestyles in reduction of single-use plastics is going to come. Amcor from the packaging industry has identified that there's a likelihood of a 5% price increase, which people would be willing to pay. Overall, our subject is extraordinarily complex. And at the end of all of this, consumers don't need more info. What they need is better info. And we are very keen in that journey to help with online pack labeling. Yeah. Hello.
Go ahead. Sorry, somebody didn't mute their line. I'll take care of that.
Okay. So with regards to educating consumers, we've launched a new website, and our objective is to be able to do more detailed explanations if people have queries. We're also keen to generate an on-pack logo, a label that would say whether this is good, bad or indifferent. We are investing in the social media to do that, and we are wanting to work with brands and retailers to develop in-store communications. As Jon mentioned before, we are part of driving that circular economy. What you're about to see is what we call phase 1. Phase 2 and 3 on our journey will include the end of life analysis. But at this point, what I'd like to do is very briefly show you our system, if it comes up. Liam, can I just check with you that you can see this on my screen?
No. It's still the presentation. So it might be escape from the presentation view and
yeah. And I want to share. Liam, I'm having a problem pulling that screen up. Hang on. Can you see it now?
Yeah, that's coming through, no problem.
Thank you. So very briefly, what you can see here is that our business was a commercially driven one, such that it looks at flexibles, corrugates, cartons, labels. What we're able to do, and I'm just going to use an example of a printing machine. Within printing machines, down the left-hand side, you can see that we've created a number of different flexo printing, rotogravure machines. They could be high performance, low performance, medium performance. They could have high cost, low cost, medium cost. Within each of the machines, there are a lot of commercial activity, which is included here, and it's looking at things like John covered earlier with machine speeds and running waste. There's also setup time and setup waste, which goes part of the way to explain why prices vary from one order quantity to another. There are other financial factors to be taken into account when looking at the machine cost per hour. But in addition, we have now built in a CO2e value for every machine based on the energy that they're using in the country that they're using it. And that also applies to all of our materials. There's inks, adhesives, resins, webs. Within the production of materials, there are pallets, cores, printing plates, delivery, secondary consumables, wickets and grommets, and of course there'll be packing materials. We also, because we're a financial tool, but I'm not going to expand on that much further than to say materials don't necessarily all come from the UK, so we also have a range of exchange rates. And because we're able to track customer details on behalf of the people that produce packaging, we're able to use Google Maps so that we can work out the distance for that material going from the end of production line at a packaging supplier all the way through to the packer filler or brand. If there is data available at those sorts, what we can also do is add their data to our packaging data such that you can have a total picture printed on pack at the SKU level or the material code level. So basically going from there, what I would like to do is just to go back to the PowerPoint presentation. I'm going to stop sharing that. He says my screen is frozen. Right, share content. Sorry, my system's just running a little bit slow. And can you see my PowerPoint presentation?
Yeah.
Okay, so my last slide, if you're seeing this, at the end of the day, what we're trying to do is cater to consumer demand, and we'll do that through education from our website. What I can also tell you is that we're now in consultation with the UK government on their decarbonisation strategy, talking to their team, because what we spent the last 3 years developing and getting to this point, the UK government a couple of months ago launched their decarbonisation strategy, which would appear to be wholly aligned with where we're coming out, such that we are able to provide transparency and using on-pack labelling in a simple way wherever possible. And ultimately, that we can meet the sustainability goals, not just to do with recycling, but now holistically reducing carbon impact in packaging. Over to you, Mr. Chairman.
Excuse me. Yes, thank you very much indeed. So to everybody on the webinar then, hopefully you've really enjoyed that session. I've got a few questions we're going to cover off, but just to sort of summarize, John has gone through really the detail about life cycle assessment, and it was quite broad, but then it's quite a deep subject. So the point there is that you need a good process. How does that translate to most of us in the packaging industry, who of course will be most of us in the webinar today? Well, Dad or Tim has kindly enough shared an example of what that could look like. You know, contact the team at Benchmark if that's somehow relevant to you. But equally, if you go on your own life cycle assessment journey, you know, the slide deck will be available. It's so important that you follow the steps that John was promoting, and then that you can see almost demonstrated in the Benchmark system. Only that, you know, making sure you consider all these points. And I have to say, as an analyst myself, translating some of the data that you have to look at is really quite difficult. It's certainly not straightforward. There's a lot of it. Choosing the right data and then using it in the right way is somewhat tricky. So just to say, Jon and Dad, thank you very, very much for your presentation today. I'm just going to come to some questions. So the first one I've got is from Kirill Dimitrov. And this was a question to you, Jon. So if you wouldn't mind popping your video back on there, please, Jon, and unmuting yourself. He says, how do you know, and what do you consider when it comes to end of life of new packaging formats that are not available at present?
That's a good question, and I think that this is often what we end up doing, especially on the research side. As you can imagine, we're often trying to evaluate materials that aren't on the market yet, or that could be, and we really need to start thinking about the hypotheticals of understanding, would this be compatible with the existing infrastructure that we have? If we're talking about a completely new material, that's definitely going to be a challenge. To create a secondary market for that material, but trying to plan ahead to understand what those requirements would be to enable that circular management of a new material or a new packaging product, if it were to be deployed, is the sort of approach that we try to take there. It's definitely full of uncertainty and it's full of hypotheticals, I suppose. But I guess trying to chart out, what would our consequence be if we only had conventional waste treatment available? What would the consequence be if we had the best possible waste treatment available for this particular packaging solution?
Thank you very much, Jon. I'm going to come to a second question by Kirill as well. He said, I would assume that the LCA is still an opinion against certain factors stroke impacts rather than a number with some expectations. With some exceptions, sorry. So how do you know what factor stroke impact is more important when it comes to a mixed comparative result between two formats?
Yeah, so that's a good question as well. So there's different approaches that we can take. I take it the question's asking about the trade-offs and how we analyze the trade-offs there. So,
yeah, I would read that. If Kirill, that's not the case, please unmute yourself and jump in. But yeah.
So when it comes to these trade-offs, one thing that we can do with the LCA results is we can look to normalize them and to try to understand what that, how important is this increase or decrease in a particular impact versus the overall impact. So we end up with very small numbers, but essentially what we would do is we would take our measure of greenhouse gas emissions that we've measured for a product, and we divide it by the total amount of greenhouse gas emissions produced in, let's say, the UK or in Europe. So we end up with a very small number, but we do that with all of our different impacts, and then we can see that relative contribution. So we can start seeing which impact is more or less important. That's a sort of numerical LCA methodology way to go about it. The other more probably easier way to go about it, and maybe the more sensible way to go about it, is to think more about, what are the motivations of the stakeholders that are making this decision? What are the policy signals telling us we should be doing, and what should we be prioritizing if we do see those sorts of trade-offs? And I think that's where decision science is an imperfect science, and LCA doesn't make decisions. What it does is it gives us that data to help to inform those decisions going ahead. So unfortunately, I think you're left to. We like to pass it on to other people with that have that responsibility and say thank you very much.
Well, the next question is from Tony Duffy, and Jon, this was to you as well. You need to be a little bit careful how you answer this next one, given the audience, of course, but is the current demand for less plastic likely to be good or bad when we consider the whole life cycle assessment?
Well, as I'm not entirely sure of the nuance of the audience I'm speaking to, I may be about to stick my foot in it. So I'll go for one of those non-answer answers. I think it really depends. I think that there is a lot of potential to better manage the plastic that exists in the economy, whether it's packaging or other applications. But there are opportunities to have more circular management to make sure that we're recovering higher value materials at the end of that recycling process that we can put right back into the same high quality uses as it had initially. I think that's a gap that we have when we look at plastics currently, but that's not an insurmountable gap. There's definitely an argument to be made there that we could continue to use plastics, but we could use them more sustainably. If we think about carbon impacts, the biggest greenhouse gas emission that happens with a plastic material is if we burn it. And if we release all that carbon that's contained in the plastic, that's going to be the biggest problem. So avoiding that from a greenhouse gas perspective is probably a really good plan. There's, of course, issues around availability of petroleum, of feedstocks, thinking about environmental consequences. If we want to start getting down to low or even negative emissions, we can start doing that with biomass-based alternatives. So we could look towards producing like chemically identical polymers, but coming from a biomass resource. So we're looking at that with a couple of options with different industry partners at the moment. But there's also the option of trying to bring in new polymers. Then we get into Kirill's questions and the challenges there of how do we create that infrastructure to deal with those new materials at the end of life. But I think there's ways to use plastic better than it's being used currently and to address the issues that exist. There's other solutions that would take us away from plastics that would have their own benefits and disadvantages. I don't think it's a simple answer.
I will complement that with one thing. We've started running some initial numbers on our system, and actually to the point there, is plastic like to be good or bad when we consider the whole life cycle assessment. Some of the initial numbers we've seen from our system, and you got to remember it's still new, we're still playing with it ourselves for the first time. It depends on the application, to tell the truth. You wouldn't want to see pizza boxes in plastic. That would make absolutely no sense. But similarly, I wouldn't want to see a pack of cheese in a paper-based solution. So numbers suggest from our system that doesn't make sense. So again, it's application by application. But and I think, to Jon's point, make sure that you're looking at good, reliable data. Then your decisions will be informed. So I do want to move on to the next question here. So from an LCA point of view, this is from Rob Goodwill. From an LCA point of view, many brands are moving from all PE collation shrink to board wraps. Is this a good or a bad move? So Jon, collation shrinks would be the sort of shrink plastic that goes around a pack of 6